Alright, today we looked at extrema, dealing with the first derivative. We all naturally know what a maximum or minimum value will be. What we're looking for is the highest point on an interval. So for example, even though this point right here isn't the highest in the entire function, it is still considered to be called a relative minimum. This is a relative, or I'm sorry, not minimum, this would be a maximum here. Also, this point over here would be a relative maximum. Now, something else that we can look at is also minimum, same thing. There would be 2 points that would be called relative minimum. We're going to be using this term a lot here in the next few weeks when we're doing with calculus. We call these extrema or extreme values, and what we're going to be doing a lot of is finding these extreme values. What we're going to find out is the way to find them is, well, look what happens. We're increasing, then all of a sudden we're not anymore. Now we're decreasing. Right here we have what we're going to call a horizontal tangent. Well, what's the slope of a horizontal line? 0. How do we find what slope is? We take a derivative. So what that means is that whenever we have a derivative equal to 0, that's when we have an extrema. That's when we have what we call a critical point or a critical number. So the critical numbers are just the x values where f prime equals 0. So the same way I could call a critical point then would just be a point that is x comma f of x, and it's wherever x being your critical number and f of x, whatever your function value is at that point. So we looked at a couple examples. Find the critical numbers of this. So of this function. First thing you want to do is take the derivative of the function. So we have 6x squared plus 18x plus 12. Next step is we want to set this derivative equal to 0 because we want the derivative of horizontal tangent. So 6x squared plus 18x plus 12. We want to factor this. We can pull out a 6, so we're left with x squared plus 3x plus 2. That means that 0 equals 6 times. If I factor the 2 to add 3, x plus 2 and x plus 1. So that means that my answer will be x equals -2 and x equals -1. Those are the critical numbers for x. Now, the second part of this is going of these problems will say something like find any relative mins or maxes, minimum, or maximum. And this is how we're going to do this. I want to draw a number line. And we're going to say, well, okay, I know I have critical numbers at -2 and -1. What are my functional, or I'm sorry, not my functional, my derivative values at these points? Well, we know at -2 and -1 is 0. What we need to look at is each individual interval around these critical numbers. So what's an easy number I can plug in that's greater than -1? Well, how about 0? So I want to look at what f prime of 0 is. F prime of 0 would be I just plug in 0. I don't even care about the number. I want to look at the sign. So I'm looking pretty much at this part of the equation right here. So I have a positive number times what would be a positive times another positive. So no matter what, I'm going to end up with a positive number here. That means we have a positive slope. That means my graph is increasing right now. It's going up. Okay? In between the two numbers. So say something like -1.5. Something like that. Well, we said positive for f prime is 0. When we plug this one in, 6 will be negative. Or I'm sorry, 6 is always positive naturally. This portion will be negative. This portion will be, I got that backwards. Positive, positive, negative. Either way, positive times negative is going to give me a negative answer here. So that means I have a decreasing function because this was negative. And same thing, something that is more negative than -2, so say -3, and we'll have 6 is positive times, this will be a negative, this will be a negative. Negative times negative is positive. That means that I'm going to have a positive number. That means the function is increasing at that point right there. So what this means now is, at the point -2, if I go from increasing to decreasing, I'm going to have a maximum value right there. And when I'm going from decreasing to increasing, I'm going to have a minimum value at that point. So my answers are relative maximums and relative minimums. Well, my relative maximum will be at negative 2. What is my functional value at that? I would plug in and find what the functional value is, which is in this case negative 18. And then same for my minimum value. My minimum x value is negative 1. I plug that in and I'll get negative 19 for my y value. Those are my maximum and minimum points. All right, let's look at another example real quick and see how we can set these up. We want to find the relative maximum and minimum for these problems, for this equation. So the same thing, I'm going to find f prime of x, and that's going to be, in this case, 9x squared minus 9x, minus 6x minus 36. Again, set it equal to 0. I can pull out a 9. No, I cannot. What am I doing? You'll have to forgive me, sometimes things get a little bit crazy. So no, let's try this whole problem over again. This happens. F prime of x will equal 3 times 2 is 6x squared minus a 6x minus 36. I'm setting it equal to 0. I'm going to factor out a 6, so I'll have x squared minus x minus 6. That will factor out to be 6 times x minus 3, x plus 2, which means x will equal 3 or negative 2. Okay, same thing as before. We want to try to draw a number line here to see what we're looking at. So here we have negative 2, and here we have 3. And I want to see what is f prime of x in each of these regions. When I plug in something bigger than 3, we're going to have positive times positive times positive, so we're positive here. 0 in each of those two critical numbers. When I plug in something that's extremely negative, I'll have a positive times a negative times a negative, which means positive. And I'm going to end up with negative in the middle, because positive times this will become a negative number, and this one will be still a positive number. So that's why we have negative there. So again, that means if I kind of want to sketch the curve, it would look something like I'm going up, and then I level out, and I'm back down, and then I go back up again. So we're increasing, so that means this is my maximum, and that means right here, this is my minimum for the function there. So that means, again, a relative maximum would be when x equals negative 2. The relative minimum would be when x equals a positive 3. Then it would be 58 for my y value when I plug that in, and negative 283 for that minimum value when x is 3. So that's how you end up finding relative maximums and minimums, and we're going to push into doing something called a first derivative test very soon. But the one thing we wanted to also talk about was finding extrema on a closed interval first. So what I mean by that is when we do this on a closed interval is that, if I can get this out of the way, we want to find on this closed interval. We do everything the exact same. We want to look only, though, in this given range that we have here, and we must check the endpoints as well. So same exact issue. We're going to plug in, we're going to find f prime of x. We're going to get 12x cubed minus 12x squared. I'm setting it equal to 0. I'm going to factor out a 12x squared and have x minus 1 left. That means I'll have x equals 0 and x equals 1 as my critical points. So what we want to look at, again, is on a number line. And we would say, okay, here's 0, here's 1. How's my function looking? Plugging in f prime of x, well, we got zeros here. We're going to have, when it's bigger than 1, we'll have positive times another positive, so I'll be increasing over here. Between 0 and 1, well, this number is going to now be negative. This will still be positive, so it'll be decreasing. And on the less than 0 side, this is still going to be negative, and this is still going to be positive. So we're actually decreasing again on this side. So that means we really don't know what this is. This looks to be a relative minimum on this point right here. Now here's the other thing. We want to check the endpoints. So what we're going to have is, for the point x equals negative 1, because that's an endpoint, x equals 0, x equals 1, and x equals 2. And that's because this is an endpoint, this is an endpoint, and these are two critical points. And we want to look at what the functional value is for each one of them. So I'm going to say that f of -1, when I plug that in, I will get, for an answer, I should get 3 plus 4, which equals 7. For 0, I'm going to get f of 0 is equal to 0. For 1, f of 1 will equal 3 minus 4, which is -1. And then for f of 2, I should get f of 2 is equal to 16. So when we look at all this, what is the absolute? That's what we're looking for, is something called absolute max and minimum. Well, on this, what I want to call it, on this absolute interval, the absolute minimum and absolute maximum on the interval are like so. 16 is the biggest, so that's the absolute maximum on the interval at that point. And then the same thing, the absolute minimum will occur at this critical point when x is -1. This will be my absolute minimum on the point. Now, the endpoint doesn't mean anything. This critical point could have still been a relative min or max, but it's going to be neither in this case because it's not a minimum or maximum. We're not going downhill, then back uphill, uphill, then back downhill. So this is just a little brief intro to how all these extrema are going to work. We're going to see a lot more examples moving forward, especially when we start doing the first derivative test. Thank you for hanging in there with me on a rough day.